I'm going to introduce David Willett. The little I know about him is from his appearances promoting shipworms as a seafood. He got in touch with the society, expressing an interest in the society supporting some of his work that he's doing at the moment. But we said, well, what we really like to do is hear more about it. So if you could come and give us a talk, and he agreed quite readily. So I'm really keen to find out what it's all about. So thank you very much.
So thank you, much appreciated. And again, many apologies today for the engineering works and slight delay in. But on to more important topics. What I'm going to talk about today is where we can try and turn wood into food and restore coasts at the same time, leveraging what is the world's fastest growing bivalve, the naked clam. To set some context, our global food system urgently needs solutions. We've got a land pressure, agriculture occupies huge areas of land, and it's the primary driver behind biodiversity loss, affecting about 80% of species at risk. We've got a major issue with greenhouse gas emissions, to the extent now that climatic change is 10 times faster than the greatest mass extinction event ever, which killed over 90% of life. We also have a protein micronutrient gap. Around 2 billion people plus worldwide are micronutrient deficient, not only in developing countries, but also in the developed countries. This is a major issue. There are, however, some solutions. One example is bivalves, things like oysters, clams, and mussels. And these are one of very, very few foods where the more we farm, the better the environment gets. That's not very common. So when I set up a mussel farm, that farm acts as a natural water filter. They filter out plankton, detritus, excess nutrients, and algae. A single mussel can actually get to about 50 litres a day. 25 sort of 2 litre bottles of Coke, effectively. Big. That's big. These guys restore habitats too. So when we set up a reef, it acts as a nursery habitat for fish, invertebrates, and other aspects of the marine ecosystem. That's beneficial. These farms also benefit us from a carbon perspective. They're often a carbon sink, locking away carbon from the atmosphere, and they don't require feed, fertilizer, or fresh water. This does mean they can contribute towards circular economies, not only as a food product, but also as the shells themselves can be a byproduct for cement manufacture, road materials, or soil additives. There's some sideline work we're doing at the moment looking at how we can use shells to actually increase fertilizer yield. So some environmental benefits, and actually this is shown again on the left-hand graph here, where we compare the environmental footprint of bivalves in blue in the center against other meat and plant crops. So you can see around the outside we've got beef that has quite a large footprint, but actually even the things like rice, soybean, and wheat have larger footprints than bivalves. If you look at eutrophication potential, greenhouse gases, water, etc. So good environmental benefits. They're also nutritionally very good. If we look at the graph on the right here, we can see again the blue polygon for bivalves. And you'll see that in terms of B12, zinc, selenium, vitamin A, iron, no other food can beat it. That's quite special. What's exciting is the untapped global potential for bivalve aquaculture is enormous. Today we produce about 2.1 million tons of meat annually from bivalves. If we use just a third of the coastline, which is not used for other purposes at the moment, we could produce 170 million tons of bivalve meat each year, which would feed 1 billion people with all their protein if they ate nothing but mussels. It's a huge number. I don't think it's realistic to get to that level. What you can see is there's a lot of potential here which has not been taken in. Even in the small UK, we've got potential. We produce just 2,700 tons of mussel meat. If we took a 30-metre strip around the UK, just hypothetically, and filled it with mussel farms, we could produce 6.5 million tons of mussel meat per year, about triple the current global value, and enough to feed many, many people. But just 10% of that would still feed 4 million people all their protein. Also, that new sector will be worth £3.5 billion per year wholesale, which is over triple the value of the UK's most valuable sector at the moment, salmon. So again, outstanding potential for a very kind of lowly and seemingly cheap product to farm. But it's all a bit overexciting here, isn't it? Because actually, it's not doing very well. If we look at production overall in 2023, that was bivalves there, 2.1 million tonnes compared to the rest of fish and seafood. And of course, if we look at consumption, it's even worse. I don't really want to show you this graph actually. The UK down here consumes about 0.1 kilos per capita per year of mussels. Other parts of Europe do slightly better. Of course, Shandong in China is doing rather exceptionally well, 100 kilos per capita per year. It's an exception. So that's the regular bivalve. But let's just take a step back in time for a bit. I'm sure you've heard of Columbus. Now, Columbus on his fourth voyage to the New World was actually stuck in Jamaica for a year. And he was stuck because something ate his boat, and ate his cruise boat as well. And that something was a bivalve, actually, a wood-boring bivalve, a Teredinidae clam, or a shipworm. These bivalves love wood. They can munch through meters and meters of wood. There are some which get to 2 meters in length. These have been the scourge of the British Navy, Viking longships, etc. We're sitting in the channel at the moment and munching through old French and Spanish vessels. They're in the North Sea eating Viking longboats. There are a lot of them, and they've been a pest for many years. Here's what they look like. So you can see a piece of wood here. These sort of white, clammy type individuals are shipworms. Now, would you eat these? Hands up if you eat them. Yeah, one person? Maybe two, three? Okay. But let's take a stop there and we'll see what happens at the end of this. First thing to try and get this maybe food into something more appealing is a name change. One of the things we did early on was dub them naked clams. They're a wood-boring bivalve with no real shell, so it's a naked clam. And actually, this is a recipe picked up by the mother of one of my master students in the Philippines. So it's wild-caught shipworms to the recipe of a celebrity chef in the UK. Yeah, like sort of batty calamari, really. And it's quite an interesting proposition. We've got a chance to connect two very strange sectors, the forestry sector with the seafood sector. That doesn't usually happen. But the concept is we can take sustainable wood waste from forestry, leverage what is the world's fastest growing bivalve, and turn it into a source of nutrient-packed protein. That's quite interesting. And some progress has been made. What we did in the lab in Cambridge and also in Plymouth is we made the world's first aquaculture system in a tank for these animals. But that was rather tricky because if you know about breeding shellfish, closing a reproductive cycle is not easy. It's quite tricky. This was a major achievement which we did for 2 species in the end. And we now have a system which in theory could encompass a hatchery phase, a grow-out phase, and a harvesting phase. You will see up here, these are kind of young juvenile naked clams. Up here we've got wooden matrices. They're blocks which we use to seed new tanks with juveniles. And we've got some more developed formulations of those which allow more rapid growth and ease of harvesting. Also in these tanks, you'll see that some of these naked clams have siphons. Just like a mussel or a clam, they filter food as well. So and we can use this to give them supplemental feed. As a result, we have a system. Naked clams are trademarked. Whether it will go anywhere, we're not sure, but it's trademarked and it's proprietary at this stage. A bit more on the animals themselves. What's quite special is that these organisms have a way of unlocking energy we couldn't access before. I've said they're a way of converting wood into protein, but that ability is delivered by a biochemical weapon, effectively. Inside their guts, they host symbiotic bacteria and fungi, which allow them to break down that wood and convert it into nutrient-dense proteins, carbohydrates, etc. That's critical. And they use the wood, obviously, for protection too. What you will see is, it's in a typical animal, you've got a wood-eating jaws up here, the body, and then the siphons at the other end. Interesting fact, though, this wood boring structure up here, it actually inspired the drills which did the Channel Tunnel and also the underground. So that was quite a long time ago, and it's quite a special drilling structure. I can't show you today, but we do have the world's first pictures of this happening in action. Hard film. It needs a special microscope. What I can show you, though, if this works, is some filter feeding. So what you can see here is inside the wood, you'll have a wood boring animal. On the outside, it's sticking out a siphon. So the long siphons are the inhalant siphons, the short ones, the exhalant. And they'll filter feed out algae, other detritus from the water. Actually, a slightly larger particle size than the bivalve as well. And that really encompasses why we've gone for a dual fuel feeding approach here, like a hybrid car. So we've got that wooden matrix structure, which we can use sustainable wood sources for, develop for growth and harvest. But also we can use a filter feed. One thing we designed for mussels and clams many years ago was what's called a biolet. So a microencapsulated feed, like a football, of around 100 microns across. What this actually is a tasty sphere with a special coating, which makes the sphere very palatable to bivalves. And you can fill that sphere with a perfect formulation of nutrients. Some examples, we've used these spheres to fortify oysters with vitamin A and vitamin D, so that one oyster can give you all your requirements the whole day. We've used them to flavour mussels garlic butter flavour before harvest. So they're flexible vehicles. And if we combine that technology with the potential of a naked clam, it could lead to some interesting outputs. We could have, garlic butter flavored clams or tomato flavored clams, whatever you want. Other thing, though, is the wood matrix itself will also influence flavour. So if we grow our naked clam on mahogany wood, that'd be rather expensive, but it would have a very different flavour to those grown on pine. And the wood compounds do leach into. Okay. All good. The wood compounds do leach into the tissue flavour, a bit like a whiskey is influenced by the kind of the wood it's held in. Now, just like for bivalves, there is some potential here. This map was a nightmare to produce. So if you ever tried looking up shipworm in the academic literature, almost nothing comes up. And that meant the only source for information here was going to be old shipping logs. So I had a very poor master student who spent a whole summer browsing through all of the old shipping logbooks from about 1500, looking through sailors' reports of what ate their boats. And we managed to find about 24 different species distributed worldwide across all latitudes, ranging from Australia to South America to North America to the Scandinavian countries. And what we've got in this graph here is squares where we have presence of the animal. Where there is a circle, we have reported growth rates. And you can see there's some fast-growing species reported in India, North America, Europe as well. This map is not complete. It does correlate quite heavily with where the Brits were in their colonial exploits. So there are some gaps which are probably not actually gaps. In terms of areas of very heavy density, we know that Southeast Asia around Thailand and the Philippines, we know that Panama and the Ecuador area, and we know that Australia are actually very rich areas for these animals. But we have them now in the UK, we have them in Europe as well. The growth rates. If you look at the far, sorry, this has gone blurry with the PowerPoint, I think. If you look at the far left-hand side of the graph, where the orange arrow is, that shows the growth rate of a mussel, a commercially farmed mussel which has been bred for hundreds of years for optimal growth in wet meat weight gain. All the other plots on the graph here show different naked clam species and their growth rates. What's quite interesting is all of those, well, most of those species have a more rapid rate of growth in terms of wet meat gain than our commercially farmed blue mussel, despite the fact these are never being bred for food. So even with very little effort, there is potential we could see, a triple or a 3 times faster growth rate in terms of pure protein mass compared to a mussel. That's quite useful, perhaps. There are some values here which are rather greater, sort of 10 times greater. I think they need validating in a proper setup first, but I think we can comfortably say there's potential for a double growth rate. Now, remember, we're still at a lab scale system, and to take this up, it's got to go to an open sea system or a terrestrial system at scale. We could take naked clams into the open ocean. We'd have to deal with issues around structural integrity, durability of any kind of marine structure like this raft here. We'd have to work out how to harvest them. We'd have to work out how to make it sustainable, and also work out how we avoid issues with, quite frankly, pest control. These animals do bore into wood. It's not an issue to the same extent nowadays with steel vessels, varnishes and coatings for wood, but it could be a problem. If we try to produce these animals on land terrestrially, we might try and do it in a shipping container, as you might produce kind of insects, that kind of thing. This will allow very high output production with high quality and high growth rates, but you need to think about where it could go and what the cost might be. So environmental benefits there and some practicalities. Like the mussels there, we need to look at nutrition. And the good news here is they are nutritious. So headline results from the first nutritional profile of naked clams undertaken 2 years ago. They have 70% more B12 than mussels. That's quite a lot, given I just said about 10 minutes ago that mussels were one of the richest sources of B12. Oddly, they're rich in the same fats you find in olive oil. Who knows why? But that's the case at the moment. They're rich in protein too. And of course, leveraging our microencapsulated feeds, we can give them an omega-3 uplift. So a nice nutritional profile there. That's what's been tested, what we've proven with research. There are many other claims. If you go to Palawan in the Philippines, they will say that these animals are great aphrodisiacs. They will say they're brilliant for pregnancy. They will say they give you the best immune system in the world. This has not been tested. It does need testing, sure. We haven't done it yet. That's one of the bits of research we'd like to do. Just for some excitement here, this footage was taken this year, and it is the first footage we know of a naked clam emerging from its burrow. They were thought not to do this, but it's happened here. You can see here the wood boring head and the rest of the body going back into the wood. This specimen actually decided to exit the wood, sit in the bottom of the tank, and lasted for about a week before eventually deciding that was a day. But it's interesting, and it may mean there's ways we can actually produce these animals without wood matrix around them. It's sawdust. So nutrition, environmental profile. But still, would you eat these things? What we did last year is we used AI. I'm always a bit suspicious about this, but it was useful here. And we looked across all the social media platforms. About 40 million views, 1.4 million likes, and thousands of videos and comments. And we basically searched for any cases in all languages of people eating naked clams, by whatever name they were called in that country. Before people decided to try naked clam, about half thought they'd like it and half thought they wouldn't like it. Once they tried them, though, 84% liked them. That's quite interesting. If you can get people over that hurdle of trying the food, most of them like it. Quite useful stat. And as a result of this, we were contacted by the Financial Times, and they actually said, okay, you say these things are good, prove it. So they went out to some celebrity chefs and they brought together some recipes. And we decided, okay, let's get them cooked. So we had recipes ranging from naked clams macerated in fruit on ice to Naked Clam rolls. Here was the winner though, Margot Henderson's Naked Clams battered with capers and green beans. This was cooked by Jessa, one of my students, and served up, and actually was pretty good. What this now leads on to is what the routes to market could be for such a food. And there are three kind of broad categories you can imagine. It could be a niche food, a whole animal novelty. On the left-hand side here, you can actually see raw naked clams being served up, in this case for battering first, but it's an interesting visual appeal. It could be an ingredient. You can mix them, strip them, batter them, and use them in processed foods. Or it even could go in a kind of a mainstream blended product. So we've got a kind of battered naked clam on a roll here, or something that you can put in a ready meal. We expect an ingredient first strategy will be the best bridge to consumer acceptance. That does, however, require you to hit a production cost which is appropriate to sell to that kind of format. If production costs are too high, that won't work. And that really leads on to the hurdles here. So I've been quite positive about this project, but actually there's a lot to be done, and there's a lot to be done to actually make any kind of success of this. Firstly, we have a tank in a lab, basically. That's not a scaled-up system. And in order to get to any kind of scale, we need to work out how to produce a high volume of juveniles and then put it into the open sea or a controlled indoor system. And that needs to be optimized for the best possible yields. We also need to optimize the harvesting as well, and work at how you can actually develop some of those innovative food products. We've gone quite a long way on this right-hand side of the graph here. Sorry, right-hand side of the table here. The left-hand side needs more work, particularly. And of course, there's regulation. We're working with an animal which was once a pest. That needs approval. DEFRA have approved it actually, but there's still work to be done. And of course, if there's any kind of trade of these animals going on, as there is in the seafood sector in general, one needs to ensure that these things can cross borders easily. As an example of this, if I'm a fisherman off the coast of Norfolk and I'm fishing whitefish, that whitefish will be sent to China, processed in China, and sent back to a restaurant on that same Norfolk beach to be sold. Fishing is a global industry. It works economically because of the scale and because of where processing is most efficient. For that to work for this kind of product, again, we need the ability to do global trade. That requires regulation. If any of you are involved in bivalves more generally, you will notice that with Brexit, we had a nightmare with shellfish production in the UK because we were cleaning a lot of our shellfish overseas in Europe. That didn't happen very easily. But if it works, there is potential. I've listed just 8 of the UN SDGs on the left-hand side here, ranging from life below water to zero hunger to climate action. A naked clam farm would hit all of those 8 targets. And there are potential market segments it could enter, ranging from, I say, fish feed up to foods, to pet foods, chicken feeds, fish feed to pig feed, etc. Very conservatively, with a small percentage inclusion in those ingredients, we think the naked clam sector could be worth $10 billion a year at current value. So a value. It's all estimated at the moment. And that's based on about a 2% inclusion rate in those foods. So potential for scale. But I want to touch a bit more on the environmental benefit of this, because this is a kind of an ecosystem project at heart. Hopefully this will play. Good, good. We can see here is my colleagues, John. John is out in the Wadden Sea in Holland, and he's installing a tree reef. He's got a load of old pear trees, and he's putting a raft of them into the water. And that raft acts as a seeding ground for these animals. So they get attracted to the wood, they start to breed, they start to reproduce, and we get a hive of boring activity. This could be quite a useful structure to seed out new farms. You imagine your pre-formulated farming blocks, whatever it is. You need some kind of vehicle to get new individuals to the site. This could work. What we know is that about a meter cube of softwood can yield about 25 kilos of mass of these animals. And when we put these habitats down in the water, they create a matrix of burrows and cavities that act as a habitat for other species. And they support a real food web right from the bottom upwards, creating, again, just like a mussel farm does, habitat for shellfish, sponges, fish, etc. One video I can't show you yet because it's in production for a paper is a video where we put out some tree reefs in the Wadden Sea in areas which were previously very bare, just covered in crabs, basically. We put down tree reefs for 2 years, came back, no crabs left, huge numbers of fish, as in 10 times more fish than you had before, eels, etc. So quite a big ecosystem shift, eutrophic shift. And that leads us to think about what else could we shift here. Well, one logical shift is to look at the world, one of the world's most important ecosystems, where the naked clam is present, and also one of the ecosystems which is most under threat by agriculture, i.e. the mangrove. Mangroves are big carbon stores. They offer valuable coastal protection. They're nursery habitats for fish. They are also humanity's favorite thing to chop down and put shrimp farms in. We look at Southeast Asia, this is a favorite activity to go from a nice mangrove to something that looks more like that left-hand side image. The question we want to ask is, could abandoned shrimp ponds become a vehicle for regeneration if we use naked clams? You can imagine, set up some rafts and reefs of naked clams here, try to rebuild that community structure, we can see a mangrove regenerate. We know that naked clams like mangroves. If you go to a mangrove in Thailand or Philippines, these animals live inside the mangrove trees when they're alive. The mangroves actually quite like it. It does benefit their overall ecology. So potentially, these could be a restoration vehicle. And then yes, there could be sustainable fishing, sustainable shrimp farming, which goes on alongside this, but as part of a long-term system that's viable, rather than a destructive system. That leads us on to where we'd like to take this next. And one of the things myself and my colleague Ruben Shipway did last year is we set up what's called the Marine Wood Borer Network. And this aims to try and take this field forwards and try and deliver some of the benefits it can offer. I've spoken today about benefits regarding aquaculture and potentially ecosystem restoration, but it's a wider field. There's cultural heritage here. We're looking at old shipping, old vessels, actually, starting to discover new species could lead to some new discoveries. I mentioned the symbionts in the naked clam gut. Yes, they break down wood. They do other things too. There are some species which live in sulfur vents and live quite happily in that environment. There are some which bore into rock and use that as a food source, different bacteria and fungi. So there's a variety of different kind of biochemical activity going on here. We also know that they synthesize antibiotic compounds. These antibiotics are very unlikely to have been seen by human pathogens. So there's potential here for new opportunity. That's an exciting area of work which is being looked at. Of course, there are other areas ranging from biofuel production to new forms of model systems, etc., which I won't go into now. The reason for this platform, the Marine Wood Borer platform, was to try and bring these guys together and try and connect ideas globally. And there was a launch issue which went out earlier this year. If you are interested in it, please do look at the website. Please do follow us on LinkedIn, and they will be able to find a bit more information out. We've got an event planned later this year as well, location TBC. So back to that question, who would eat a shipworm? More than 3 people?
Yeah, I'll try it.
More people. It's going to take a while to convince you. A few more recipes, and maybe some more appealing species. We'll get there. But thank you. That's all for today. I welcome any questions.